wanted to follow up on lecture 18, and more specifically this question right here where we had the circuit with two light bulbs A and B, and you remove light bulb B, and the question was what happens to the potential difference between points 1 and 2, and the answer was that they increase. And so let's look at this, and so we'll draw the circuit out, and I want to make one sort of simplification here. So here's the resistor and a light bulb, and then here's resistor and a light bulb. Now I'm just going to, just to make this a little bit easier on us, I'm going to call the resistance of the light bulbs to be the same as the resistance of the resistor. Okay, since they're identical resistors and identical light bulbs, it doesn't really change the final answer we get. It just makes it a little bit easier to deal with. And so what I can do is I can replace this circuit with the equivalent case of basically if I just combine the light bulb and the resistor of two guys in parallel that have resistance of 2R. And so since these resistors are in parallel with the battery, okay, the voltage drop across them has to be the same as the battery. And so what's going to happen is the current going down here would just be the voltage of the battery divided by 2R, and the same thing with the current going through here. And so the total current that the battery is pulling out would be E over R. And then at this juncture right here, it splits into two. And so if you look here, since these guys are in series, they're going to have that same current of E over 2R coming down right here. Okay, and so this was our light bulb B. If I call this, our resistor B, then the voltage drop for resistor B is just going to be its current times its resistance. Well, the current there is epsilon over 2R times R, and so it's half of epsilon. So basically the voltage drop here, delta V, is half of epsilon. I do the same thing over here, and so this voltage drop here is also half of epsilon. So because the current has to drop a little bit through resistor B, okay, it can't do the full voltage drop for the light bulb B as well. All right, and now, so that's what it is beforehand. Now afterwards, if we have the same circuit, so I'll just draw this again, but this time we remove the light bulb, okay, and this was the case that was kind of tricky. If we remove that light bulb, it's a circuit that's missing a link, and so the current can no longer flow. And so the current that goes through here now is 0. So if I do I times R to find the voltage drop, it's 0. And so basically what that means is that any point on this side of the wire here will end up with the same potential as right here. And since there's nothing between that and the battery, okay, so if we do the battery, this is like 0 and this is epsilon, then basically this has to be positive epsilon, every point on here. Now it'll take a few microseconds for everything to kind of slow down and equilibrate itself, but whenever you have a conductor in equilibrium, it has to have the same potential. That's one of our rules, and this is connected here, so it has to have that same potential. And then down here, it'll have the potential of 0. And so basically the potential difference for our light bulb B initially was epsilon divided by 2, and then so in this case over here, the potential difference of our light bulb B will be the total epsilon, and so it has increased. Now, as a kind of example that's similar, these are some of the same ideas. This is number, I think it's 34 from your textbook, chapter 31, and it wants to know, you want to rank these light bulbs in brightness. So why don't you stop for a second and try to rank these in brightness, and then we'll talk about how to do this example here. Okay, so when I did this, the brightness I got A was the biggest brightness, and then D and E were equal and the second biggest, and then B equals to C were finally the last ones. And so if we were to draw this circuit over again, all right, what I can do is it'll be something kind of like this here. And so I'm going to draw these as resistors. And so resistor A, they all have identical resistance, so that's like R. And these two guys here would be kind of like this here. So this would be R and R. Now I can combine these two, B and C. They're in parallel, and so when I combine them, okay, two resistors of R in parallel will be, the equivalent resistance is R divided by 2. And so if I completely, essentially break this down pretty far, so that's basically one resistor in each leg. This one will be resistance of 2R, and this one over here will be resistance of 3R divided by 2. Alright, and so if I figure the current, so I'll call this the left branch and this the right branch. The current that enters the left branch was the same thing as last time. Okay, we know they both have a voltage drop of epsilon because they're both in parallel with the battery. So the left branch, it would be epsilon divided by 3R divided by 2, which would give us 2 epsilon over 3R for the current. And in this case here in the right branch, it would be epsilon divided by 2R. And so if I go to this picture here, that means that there's a current coming this way of epsilon over 2R, so 1/2 E over epsilon over R. And this way, it's basically 2/3 epsilon over R. All right? And for a resistor, the power of a resistor is equal to I squared times R is one of the easiest ways to think about it. All right, and so if we use this here, so what happens is, so this resistor here has the biggest current of all. It's got a current of 2/3 epsilon R. Okay, so right here through A is a current of 2/3 epsilon R. Now both D and E have a current of 1/2 epsilon R. All right. And then finally, the current here splits exactly into 2, and so it would be a current of 1/3 epsilon over R and 1/3 epsilon over R. And so basically, if you look at their currents, which is sort of how we're looking at this guy over here, A has the biggest current, D and E are next, and then B and C are last, just like we said over here. So there's another example in the book, number 35. You can try this and give yourself some more practice.